All right, let's talk about mole ratios, folks, and what they really mean. Let's balance this equation first. We have methane gas, which is the gas you pass. If you combust it with oxygen, I don't recommend this, you get carbon dioxide and water. But let's balance this equation first. So 1C, looking good. 2 H's, 4 H's. Let's put a 2 in front of here. Let's count the number of oxygens. 2 oxygens and 2 oxygens, that's 4. So, there it is, 2O2. See, that's what happens as you go on old school with a pencil. 2O2. Okay. So what we have here is a ratio. For every one of these, it reacts with 2 of these O2 molecules to react 1 CO2 and 2 H2Os. So if I had 10 of these, it reacts with 20 to 10 to 20. So the ratios are, this is basically a recipe. If we had moles, well, look, 10 moles. It's a 2-to-1 ratio. That should be half. That should be 5 moles, and it's this is a 2-to-1 ratio, so 5, and it's a 2-to-2. So those two should be the same. So you see how we're using the mole ratios of the equation here, the balanced equation, to kind of figure out what everything is. Let's do this one. 1.5 moles of this, so it's a 1-to-2 ratio. That's 3 moles of this, and then that should give us a 1-to-1 ratio, 1 to 0.5 moles. And then 1.53 moles. And you keep going, and you try to go until you figure it out. And this is really nice for simple ratios. You can kind of figure it out in your head. But what happens when you have a more complicated one? Dun, dun, dun. All right, let's just do it. So what if you have C8H18? All right, so let's take a look. So here we go. Let's balance this again really quick. C8H18. 8 carbons here, 8 here, 18, 9 of those, 16 plus 9, that's 25 oxygens. So in order to get 25 oxygens, we need this to be 12.5. That doesn't work, so let's multiply everything by 2 to get rid of these whole numbers. 2, 25, 16, and 18. So this is our balanced equation. And from that, we can create something called mole ratios, which is a ratio of any of the reactants and any of the products. So let me show you what I'm talking about. Look, for every 2 moles of C8H18, it gives me 16 moles of CO2. So that could also be a 1-to-8 ratio as well. It's the same thing mathematically. And what that means is that for every 1 molecule or mole of C8H18, which is lots of molecules, you get 8 moles of CO2. It's a 1-to-8 ratio. And this is going to be really handy when we're actually calculating our carbon footprint. If we know how many moles of C8H18 that we're combusting, we could figure out the moles of CO2. It's 8 times as much. This is part of the problem, folks. Let's do the rest of the mole ratios. Moles of C8H18 to moles of H2O. Just put the number in front, 2 to 18 or 1 to 9. Moles of CH18 to moles of O2. This is a tongue twister. 2 to 25. And then the moles of O2, 25 moles of O2 to moles of CO2. Okay, so we use these mole ratios as conversion factors. So say, like that I said a second ago, if I knew the moles of C8H18, can I figure out the moles of O2? Well, looking at your mole ratio, we start out with moles of C8H18, and the mole ratio is 2 moles of C8H18 for every 25 moles of O2. So this would be a question that maybe the chip in your car would ask. So how much oxygen exactly do I have to add to combust the fuel that you're going to burn? And actually the chip in your car does that. It does it kind of perfectly to get the maximum efficiency, maximum energy out of the combustion. You can actually goof with the chips and make them combust a little bit faster and higher, but it produces more noxious gases, different temperatures, not as efficient. Okay, so here we go. This times this divided by this. Or you could think in terms of this, that this divided by this is your conversion factor, and it converts from moles of CH18 to O2, and just multiply it by that. And for that, let's see if I have the number. 1.5 moles of CH18, you're going to end up with a lot more moles of O2. And the answer for that one is 18.75 moles of O2. And you could do it for all of these reactions, this times this divided by this. So the moles of CO2 is 12 moles of CO2 and 13.5, knowing that the ratio for H2O is 18 to 2, or 9 to 1. Okay, so this is the one that we're really caring about right here, how much CO2 you produce. I mean, really, you're producing water too, which is pretty cool, water vapor. You could drink it if it wasn't so dang toxic. So there you go.